I'm going to explain how to use the periodic table. Here we have the format, the name, and all that things that I'm going to explain right now. So the first element that I want to explain is the oxygen. So first we have to put the name oxygen right here. And first the symbol, we have to identify the oxygen in the periodic table, obviously, and here it is, the oxygen. So the symbol of the oxygen, it's O. It's always this one, so it's O. Atomic number is this number that is in the top, in the left top of the box, so it's 8. And the atomic mass is this number, so here we want the rounded atomic mass, so here is 15.999, so this rounded would be 16. And now the electrons are the same number as the atomic number, so here we have 8, and the protons are also the same number as the atomic number, proton and electrons. The neutrons are the rounded atomic mass minus the atomic number. So here will be 16 minus 8 equal to 8, so neutron 8. The period is the horizontal columns that we have here. So first period, second period, third period, fourth period, and here would be the second period. The group would be in a vertical way. So here's the group. The group would be, well, you can represent like this, but in a complete way. So if you want to represent this, will be like this. But for me, it's more easier to represent it with the number that is in the top. So 16. Now we're going to search for the valence electrons. The valence electrons are the Roman numbers that we have in the top. So here we have an a B and a 1, so it would be 5, 1, 6. So here we have 6 valence electrons. So now we're going to do the electronic configuration that it's by the atomic number. So now we're going to search for the off-bow that we needed to do this. The off-bow it's right here. Let me show you. Okay, so here we have the off-bow. We have to follow this, and here the electronic configuration will be 1s2, 2s2. Here we have 4, and 2p6. The p is equal to 6, but we can change the number, the last number, to do that the p equals to the number we want. So now I'm going to do the quantum number, that is this. Okay, so here we need the electronic configuration. So n is equal to the biggest number that we have here, that is 2. So 2l is equal to the biggest number minus 1. So here we have 2 minus 1 equal to 1. So the m, it's based on the l, so based in the number that we have in the l. So here we have 1, and we start doing this. We have to initiate in the negative number that we have in the L. So minus 1, 0, 1, it will be different. It will be the same if we have a 2. It would be like minus 2, minus 1, 0, 1, and 2. And to do the M, we have to do these arrows. So we have to do with these numbers. We're going to put 2 arrows, 1, 2. So M is equal to O because the final arrow is here, and the S is equal to 1 above 2. And if the arrows go like this, well, finish like this, it would be negative, but in this case it's positive. Okay, so here is the problem gave me that we have 4 neutrons. So I identify that is the lithium by doing the operation. That will be 7 minus 3, that is equal to 4 neutrons. So here we can start to do all the things that I previously did. So here for the lithium, we have the name that is lithium, the symbol that is Li, the atomic number that is 3, the rounded atomic mass that is 7. Here we can see electron 3. Here we have the neutron that I previously explained, proton that is the same as the electron, period 2, group 1, and here we have the valence electrons that is 1, and the electron configuration that is 1s, 2s1. And here we have n equal to 2 because it's the biggest number, L is equal to 1 because 2 minus 1 is 1, m that is equal to 0 because it's the same that we did here, and also s equal to 1 above 2 but in positive because the arrows finish like this way. Okay, so by this information, aluminium, Al, the atomic number is 13. Here we can see the rounded atomic mass is 28, electron 13 also, 28 minus 13, that is the neutrons, would be 15, proton also would be 13, period with 3 and 13, and valence electrons would be 3. Here's the electronic configuration, and by this we look like n is equal to 3, L is equal to 2, m is equal to 0, and s is equal to 1 above 2, but in positive because the arrows finished in this way.